I am Anupama, a doctoral research scholar in the Building Technology, Construction Materials and Management group at IIT Madras. I research on the salt weathering resistance of masonry systems under the guidance of Professor Manu Santhanam. So today I am going to explain the working of mercury intrusion porosimeter, which is commonly known as MIP. So today in this video, I'll be explaining the working principle of MIP, the instrumentation, the major applications and the limitations of MIP. So here in this equipment, a non-wetting fluid, that is mercury, is intruded into the pores of the material. So hence, we can find out the pore size distribution and porosity of the material we are analyzing, and hence we will get an idea about the durability of the material. So let us see what are the different types of pores which are likely to be present in a material. The first being closed pores. So the closed pores are completely entrapped within the material. They are not accessible from outside. So they are not characterized by the MIP. Now there are blind pores. Blind pores can be accessed from the exterior, but they do not travel all across the material. They can be characterized. Next one is through pores. They travel all across the material. They can also be characterized by MIP. So MIP can characterize pores over wide range starting from like 3 nanometer to 1000 micrometers depending upon the pressure range we apply. Mercury has a contact angle of 130 to 150 degrees, which makes it non-wetting. Because it is non-wetting, pressure needs to be applied to make it intrude the pores. So the relation between the pressure and the pore size which it is intruding can be obtained through the Washburn equation. Washburn equation is P equal to minus 2 gamma cos theta by R. So here P is the applied pressure required to force the mercury into the pore of radius R. Gamma is the surface tension of the liquid mercury, and theta is the contact angle between mercury and the sample. Now as the pressure is applied, mercury intrudes the large pores first, and as the pressure is increased, it intrudes the smallest pores. Now that the working principle is understood, let's move to the instrumentation. So this is the mercury intrusion porosimeter. It has two chambers. One is a low pressure chamber. It has two stations, which means we can test two samples at a time. Next one is a high pressure chamber. It has also got several safety features. For example, the LP chamber and the HP chamber, both are independent. Another major feature is that it is a bench top equipment and the mercury transfer from LP to HP is at the bench level. And also we have LED readouts which shows the pressure at every point in the low pressure chamber. Several safety precautions has to be followed while performing testing in MIP. Safety gloves, glasses and lab coat should be worn every time. The mercury has to be disposed of very safely after testing, and also all the cleaning has to be preferably done outside in a fume hood because we are using isopropyl alcohol for cleaning. Let's go for sample testing. There are 4 major steps for sample testing. The first and foremost important step is sample preparation. Secondly, we have to test the sample in low pressure station, and third step we have to test the sample in high pressure station. Then the last step is data importing. So let's move to sample preparation. First we have to weigh the sample. The sample should be small chunks of about say 5 mm or 7 mm wide. Here we have taken a sample of stone of adequate size and amount. 60% to 70% of the penetrometer cell volume must be filled accordingly. Slide the O-ring to the cell and evenly apply a thin film of silicone grease to the rim of the cell. Place the cell contact assembly on the rim and twist it to maintain a very good seal. Place the upper cell housing and tighten the housing with the cell contact assembly using the spanning wrench. So first we have to switch on the system. So we need to fill about 80% of the cold trap beaver with liquid nitrogen. The sample is ready to be tested in the low pressure system. So for that, the low pressure chamber needs to be opened. Now place the sample cell with its housing and knurled ring in LP station 1. We have to insert the cell very carefully. Now slide the cell retainer over the cell and turn it clockwise slowly until the micro switches are engaged, and we have to wait till it makes a clicking sound and shows a green color. Now we can close the station.
Now, using the software, test in low pressure can be run and the data corresponding to low pressure can be obtained.
Once the testing has been completed in the low pressure station, we can open the station, remove the cell retainer, loosen the knurled ring inside the LP station 1. After taking out, we have to weigh the cell mercury sample setup. Fill the stem with hydraulic oil above the mercury level. Add threaded spacer and high pressure sheath assembly vertically to the penetrometer and then tighten it. Now we have to transfer the cell to the high pressure chamber. We have to open the HP chamber. Rotate the upper end cap anti-clockwise to open it. Now transfer the cell sheath assembly to the high pressure chamber. To close the chamber, rotate the upper end cap clockwise until it is aligned. Once the chamber is tightly closed, the next step is to purge the oil to remove the bubbles. Once the oil purging has been completed, the sample is now ready for testing in the high pressure chamber.
Like the low pressure testing, Quantachrome software can be used to test in high pressure and the data corresponding to high pressure can be obtained.
We can get the data either in graphical form or in tabular form. So let's move to the applications of MIP. It has got various applications, not just limited to building materials. It can be applied in medical sector, ceramics, pharmaceuticals, etc. So now let me show just one application from the building materials section. So here is the graph obtained from MIP. This is a differential intrusion curve obtained for the calcium sulfoaluminate belite cement before and after carbonation. So here if you see, the blue line or the blue graph corresponds to the data after carbonation and the black one is before carbonation. We can infer that pores are getting coarsened after carbonation of CSAB cement. So this data can be obtained through MIP. Mercury intrusion porosimeter has got some limitations as well. One limitation is that only dry samples can be tested in MIP, and secondly, MIP is a destructive testing. So we cannot reuse the samples once it has tested in MIP. Apart from this, there is one more challenge with MIP, that is the ink bottle effect. This is an ink bottle pore. So while analyzing such a pore, the diameter D1 will be considered as the entry diameter of the pore by MIP. So D2 will not be considered. This is known as the ink bottle effect. This is a major limitation of MIP.
I hope through this video you have understood the basics of mercury intrusion porosimeter. Thank you for watching.